Yo, 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 let's cut the music and let's dive straight into this. Hello, ladies and gentlemen, boys and girls. Welcome to VUX World. I'm your host, Kane Sims, and running a little bit behind schedule today. Apologies for that. Those of you tuning in on LinkedIn and YouTube, critically, I had left the key in the door, in the back of the door, so my wife and child couldn't get into the house, which is always fun and games when you've got a dog downstairs yapping and barking and going absolutely crazy, thinking that there's a burglar outside. And so, so there we go, trials and tribulations. But welcome to VUX World. A quick shout out to our sponsor, Deepgram, presenting sponsor for VUX World. Deepgram is one of the leading automatic speech recognition providers on the market. The accuracy rates are incredible, over 90% in many instances. Crucially, unlike some other providers, you can actually retrain their models so that if you're working with a specific use case, let's say, I don't know, you're in banking and you've got customers that are referring to certain product types or, credit cards or certain whatever it might be, have certain lexicons around your niche industry, you can retrain these models to get even higher accuracy. And as I always say, if you put crap in, you get crap out, which means that if you're building voice assistants and voice bots, if you don't have a high performance speech recognition, you're not feeding the right amount of data or the right data to your NLU, and therefore the whole thing breaks down. And so if you are in the market for speech recognition technologies, not just for building voice bots, but for building any kind of application that requires translating spoken data into text, then do check out Deepgram. You can do that by visiting deepgram.com/VUX World. That is deepgram.com/VUX World. Shout out to the team at Deepgram for sponsoring the last actual episode of VUX World before the new year. So Merry Christmas to everybody at Deepgram, and also Merry Christmas to our guest today, Stefan Scherer. Stefan, welcome to VUX World.
Hi, Kane. Thanks for having me.
No
Excited
worries.
to talk to you about robots.
Yeah, absolutely. What I've missed today from today's episode, which I used to do at Christmas time, but I stopped it because when people watch this video back again in like March, April, whenever it is, as people do, it doesn't look quite right. But I'll give you a demonstration of what I almost wore for today,
Okay.
which is this Christmas jumper, which I like because ironically Santa is actually pulling the reindeer on the sleigh. Not the other way around. So yeah, there you go. That was what I almost wear, but I thought I'd keep it evergreen today.
It's a great ugly sweater.
You got to have a cringy Christmas jumper, I think. But yeah, so we're going to be talking about talking robots today, which is a topic I've been wanting to chat about for quite a long time because it seems to me that there is certainly an emerging trend around not just in-home robots, which is likely what we're going to talk most about today, but general robotics across the board, from your likes of factories to all kinds of
Mhm.
different areas where we're seeing kind of robotics and like humanoid like robots, and the interface to those 9 times out of 10, even if you're talking about the kind of like Roomba vacuum cleaners, they're still kind of mini autonomous things that circulate around your house. And we saw Amazon announcing the Astro kind of robot and stuff like that. So it's something that is emerging where we are seeing the rise of like in-home robots. And I think that from a conversation design and an NLP perspective, this is something that I think more conversation designers are going to be working on as time goes on. So I'm certainly really curious to understand a little bit about how you've been approaching this kind of stuff. Maybe first we can get into
Great.
just
Yeah.
a little bit about what you do and what Moxie is and all that kind of stuff, and maybe just explain for people who you are, what you do.
Sure. Awesome. Yeah, let's get started. So I'm Stefan. My background's in computer science, and particularly I've focused on machine learning in my studies, both as a student as well as then as a PhD student at the university in Ulm in Germany. And so what I was fascinated by was really kind of like using machine learning or neural networks to accomplish things that the human brain seems to be seemingly like trivial for the human brain, recognizing faces, understanding language, hearing tones and changes in the voice that then relate to emotion or possibly even well-being. Like when we hear someone who's depressed, we may actually have a hint that there's something going wrong or something that's not quite right. And so I wanted to see if we could teach machines to kind of understand those kinds of nuances more easily. And classical AI approaches with zeros and ones didn't quite cut it, unfortunately. And I think that's how I got into machine learning. With a little bit of a stint in Ireland at Trinity College as a postdoc, I then ended up in the US at USC, the University of Southern California, where I joined the Institute for Creative Technologies. At that institute, which is one of the forefronts and like one of the leaders in many areas, even like VR. So like Palmer Luckey was an intern at ICT before he founded Oculus, and so ICT is really always at the forefront. And like one of the things that we built there was virtual humans that are digital representations of humans with a face, with a body, with the ability to gesture and have facial expressions. And the reason for that was we wanted to go beyond like voice interfaces only with disembodied voices like an Alexa. We wanted to have a face and a body so that people can relate, people can build rapport with these systems. Because what we wanted to do is we wanted to tease out behaviors that are indicative of depression, suicide risk, or PTSD. The work that we did there was often military funded. So the post-traumatic stress disorder is something that they were very interested in, trying to understand soldiers that return from the war theater, like how their minds and souls have been impacted by the atrocities that they may have seen. So that's how it all started. And about 4 years ago, I joined Embodied, a small startup here in Los Angeles, as the CTO, where my mission was really kind of applying all these things that I learned during my research of about 10, 15 years, and apply that to a robot that interacts with children. So Moxie was born, and Moxie is a very cute little robot. It's about yay high, like 40 centimeters or something like that. And it interacts with children. So it has to have these abilities that we humans are like very used to, like the abilities to communicate very freely with your voice, with your facial expressions, with your gestures. So we had to build this technology that is able to interact naturally with children. And as if you have children, obviously, like you may know how difficult sometimes is to even understand them. So like I agree with what you said earlier about Deepgram, right? Like one of the things that can be challenging is ASR for child speech, for example, as well. But so yeah, so we started off building that robot about 4 years ago. And we launched this year. We launched in March, so the robots are available for purchase right now. Shameless plug here, unfortunately. Sorry for that. But basically, what the main core technology that we focused on was this interaction technology. Like we wanted to be the prime company that builds the most intuitive and most robust human-robot interaction possible. And that is a very deep conversational stack, but in particular, it needed to be multimodal. So understanding facial expressions, understanding the tone of voice, and the gestures in conjunction with the language that we use. Because only then we can really disambiguate all the meaning and the intention that we perceive from the user.
Interesting. There's a few interesting things around there. I think before I ask around, I want to make a note of this though, so I don't forget it, because it's quite good. I won't allude to what it is, but why the name Moxie, out of interest?
Yeah, we were doing quite an intense search for finding the right name for our robot, and Moxie just turned out to be a really good name for a robot. We did some market research on it, but also like it used to be an energy drink, I think, and it kind of like what was really exciting to us was like, because you can say, oh, this guy or this gal has real moxie, right? Like Moxie is is kind of like embodying this idea of like having Moxie.
Nice, interesting. And so the purpose of Moxie is to help children develop emotional intelligence.
Mm-hmm.
Is that correct?
That is correct, and so I can give you the full spiel on that. So Moxie is designed for social emotional learning. What we wanted to do is we wanted to build a robot that really kind of tackles the hardest things first. Google X, the moonshot factory at Google, I think it's only called X now, but they had a saying or like a concept where they say like, oh, you have to do monkey first. Monkey first in this sense is with the explanation for it is like if you want to build a monkey that recites Shakespeare on a pedestal, you don't start with the pedestal. You know how to build a pedestal. You start with the monkey. You need to figure out how to train the monkey to recite Shakespeare. That's the hard part, right?
Mm.
So what we wanted to do, we wanted to teach Moxie to have social emotional intelligence. So before we wanted to teach it STEM, for example, like STEM for a robot is trivial, like 2 + 2, like a robot can do that. It has a CPU. It's trivial to do, but for teaching a robot what happiness or what kindness means is much more difficult. It's very weird, and how to express that also. So robots are multimodal input and output devices, and so what we want to do with Moxie is not we don't want to teach children how to interact with a robot. We don't want to teach children how to take the experiences that they have had with Moxie, where they learn how to be kind, how to make friends, and send them out into the world. Use Moxie as a springboard into life, like where they can then apply these skills in actual face-to-face human conversations and human-to-human interactions. That's really the core idea of Moxie. So Moxie is not the destination. It's a springboard into life, and that is really powerful, I think. We accomplished this in some ways. So first of all, Moxie doesn't come into your life as being a teacher or a sensei or a professor. Moxie is actually a peer. It needs to learn from you how to be a good friend to humans. So that's its backstory. It comes into the world to learn. And you are, as a child, you are going to be assigned the mentor of this Moxie. So you are actually taking a pledge that you are actually wanting to teach Moxie, and through the learning, through the ability to teach Moxie about these concepts, you learn them yourselves. So basically, like teaching, by teaching, you kind of also learn. So this is kind of like a design principle that we have applied, and that is really powerful. And so we have these missions that you do on a daily basis. So you interact with Moxie, talk about things like emotions or kindness, or trying to understand like, oh, what does that mean if my heart's beating faster? Like, oh, you may be nervous, or like you have butterflies in your stomach. Like, what does that mean? Like, can you explain these things to me? And then we ask children to then talk to their parents about these things, or do some exercises by themselves, like draw something and bring it back and show it to Moxie. Yeah, so this is the core idea, and I do see there's a question in the chat. So Moxie is for the ages between 5 to 10. So that's the core like age group that we're targeting.
Interesting. There's a few interesting things in there. That whole kind of the whole concept of teaching first allows you to learn. That is definitely a known design principle. But the other thing that is also present in there is a conversation design principle as well, which not everybody applies and utilizes, but one that I think works really well, which is introducing your assistant not as something that is all seeing, all knowing, and the single source of ultimate truth, but in fact introducing them as a very naive toddler that needs to be taught a lesson, and we'll do our best, but bear with me, kind of thing. And so rather than having your assistant as the all singing, all dancing, you immediately lower the expectations by saying, you're going to help me get better. In the meantime, I'll help you as best I can, sort of thing. So there's two really interesting principles, even just from the outset, that sounds really interesting.
Yeah, no, absolutely. You hit it on the head. Like this is absolutely the right thing. So and it like we actually use making mistakes as an opportunity to learn. So for example, these interactions with Moxie are actually quite different from an interaction with Alexa. So I like to say, when you have an interaction with Moxie, you communicate with Moxie after waking up Moxie once with one wake word. You say like "Hello, Moxie," or you rub its belly, and Moxie wakes up, and you have a conversation. You never use the wake word again. So you have a single wake word to interact with Moxie. And as you can imagine, like we are right now having a back and forth conversation that isn't necessarily 100% accurate to call it like turn taking, like I take a turn, you take a turn. Like in our conversation here, it works quite well, because this is like, you know, for a video format, we would be stumbling over each other all the time because of the signal delays and things like that. But in a face-to-face conversation, and particularly if you have multi-party conversations where you have multiple people around the table, you interrupt each other all the time. Like there's like back and forth, and so the turn taking and the like when to speak and when to be quiet, those kind of things are actually quite challenging. And we have developed some AI technology that actually recognizes when we interrupt someone. It's not super difficult to do so, but it is very difficult to maintain a very good turn-taking cadence, and like being able to interact and listen at the same time. But when we do interrupt the user, we actually take that as an opportunity to again show that it is okay to make mistakes, and to be a good person about like making mistakes. So for example, like, oh, I'm sorry, I just interrupted you. Moxie would be like apologetic and say like, okay, I sometimes like still make these mistakes, but you know, like it's a good thing to make mistakes. You learn from them. Like over time, I'll get better, and I'll try to make less mistakes in the future. But these are kind of like the ideas that we implemented there. So yeah, it is okay to make mistakes, and it's particularly okay to make mistakes if you frame the conversations as like a learning opportunity rather than like I know everything and so you should listen to me, right?
Definitely. There's a question. I definitely want to get into some of these areas that you've been touching on, which is around, you know, how do you work out what facial expressions that go with the dialogue and all this kind of stuff? How do you teach a robot what happiness means? All this kind of stuff is super interesting. But now that you mentioned making mistakes is a good thing, this has been 4 years in the making. What mistakes did you make along the way, and how has that resulted in a better end result ultimately?
Yeah, so we set out to build the most intuitive human-robot interaction platform possible, and on the way there, there you run into so many possible issues, and it like you can only learn from actually finding out about those mistakes, and like you know, like move fast, break things quickly, and iterate, right? Like I think the iteration speed is actually absolutely crucial, and you need to and test often and early. I think that's the most crucial like way toward success. So we made tons of mistakes. So for example, the turn taking was very challenging in some cases where, for example, if I think about the first times we sent robots to children's actual homes rather than in the lab, in the studio, um, there is a TV on in the background. There is a mother on the phone. There is a little toddler, baby brother or sister running around and screaming. Their dogs and stuff like that. So we had to teach Moxie really kind of like, okay, what does it mean to pay attention, to focus on one individual? We needed to like recognize the individual. Oh, that's my mentor, main focus. Don't get distracted by everything that's going on around you. The hardware doesn't always work perfectly. So for example, if you think about the blue ring on an Alexa, when you say the wake word, it doesn't always, like in particular when it stands next to the wall, it doesn't always point in your direction. where you had set the wake word from, but it sometimes goes the opposite side, or like even like the weirder angles. And so this happens all the time in these devices. And so we had to learn how to deal with these uncertainties. And I think you can plan for it, but you always, I think you have to test and test and test, and like over time you get like really a good feeling for like how to not make these mistakes in the future. Some of the main like issues that we ran into right away was we have this robot, so it wakes up, and from the very first moment, it does not give you a manual. It does not tell you what you have to do. There's no wake words, or like after you wake it up, it's in full engagement mode. It communicates right from the beginning. People start asking it anything. People go on and like ask Moxie, like, what is this? Like, how do you, like, what do you think is who's going to be the next president? Things like that, right? And Moxie doesn't know anything about these things. And we deliberately didn't want it to be like a transactional interaction like you have with an Alexa or with a Siri. We wanted it to be conversational. So Moxie right off the bat, like sometimes ran into these fallback situations where we just like, sorry, I don't understand what you're asking me. And so we had to kind of like redo how we do the Fatui, what we call it's the first time user experience. And really that was incredibly crucial. We had to redo that a bunch of times to get it right, so that it's both intuitive and it looks like it's alive. It's a character that comes into your home that immediately gets your heart beating, and like you get excited to have this new companion in your home. So that was a lot of work there, and like really kind of building upon the technology that's on the robot, and then augmenting that technology with the ability to leverage large neural networks in the cloud, and really connecting that was key to having the ability to respond to any type of question that may come up, and to be able to like deal with these challenging situations. But yeah, like lots of errors and mistakes on the way, but it's tough if you don't have a quick iteration speed. I think that's absolutely crucial to make a product like this come to life.
Another crucial lesson there, I think, is as anyone who's worked with, I think it's more complex in your instance because you've not just got a conversational interface, but you've also got hardware, and you're not just got hardware, but you've got a multimodal interface, and so it's just compounded in terms of the complexity. But for anyone who has designed, for example, a voice assistant experience or a voice bot in a call center or even a chatbot, to be honest, you really only start learning when you actually put it in front of someone. And so the earlier you put it in front of someone, the quicker you find out what actually needs to be done. And so it sounds as though you kind of took that kind of similar approach of getting it out there, getting in front of people, figure out what the actual realistic issues are, and let's kind of iterate from there. You kind of alluded to the answer to this question, but I'll throw it in there anyway. A question from Miguel. Shout out to Miguel Costa, because he was on last night's broadcast answering some good questions as well. So you alluded to cloud connectivity and that kind of stuff. So the question for Miguel is, do you do all of your kind of NLP, speech recognition, natural language understanding, etc., on Moxie, the device, or does it require an internet connection?
So the TLDR is it requires an internet connection. But let me go a little bit into detail. So there are a few things that need to be considered. So for us to be able to build rapport with like an artificial being, as well as like with an actual like other human, it is important that we have the ability to kind of connect and to have a sense act loop that is very quick. It cannot have like a delay of 3 to 4 seconds and so on. Be engageful as an interaction. And this sense act loop that basically goes from perceiving a gesture or a voice input, a language input, to understanding that input and interpreting it, to then plan a reaction, like a response, and then producing that response on a multimodal output device like Moxie as a robot. That loop needs to be like a second or less. And so what we did is we did a couple of things. So first of all, our ASR is fully streaming into the cloud, and we do partial speech recognition so that we get incremental input very quickly, and we can interpret and predict what the intent is going to be on the fly, so we can respond very quickly. We do that both on the robot, so we have our dialogue stack both on the robot as well as in the cloud. They talk to each other, they communicate with each other. If the less powerful, because the robot runs with a small chip, it doesn't have a GPU. Our robot needs to be manufactured fairly cheaply, because we didn't want to sell it like a pepper from SoftBank that cost like $30,000 or something like that. We wanted to sell this to consumers, and we wanted to have it be close to $1,000, right? So it needed to be cheap in manufacturing as well. So the CPU on the robot doesn't have very powerful abilities after it's rendering and simulating the face, synthesizing the voice, etc. All of these things happen on the robot, but we couldn't do everything. So the automatic speech recognition happens in the cloud, and then we have this separate NLP stack that it is in the cloud and leverages these large transformer networks that help us understand what the intention is, and then produce meaningful responses in case our local NLP on the robot doesn't know what to do. So that's kind of like the way we treat this. Now, sometimes the cloud gets delayed with the response, and the robot locally doesn't know what to do. So we would play like a thinking animation, things like that, that just like bridge the gap between these moments where you would think, I would need a response right now, but I don't quite have it yet. So we mask it through kind of like these natural ways of communicating for humans, like putting in a thinking gesture, or like a delay with a pause filler. But yeah, so it is definitely both on device as well as in the cloud. But it for like making it modern and making it really snappy and quick to respond, you need to go a similar route where you have something that runs on the robot itself that responds very quickly, but it probably is going to be limited. So you want to augment it with some smart choices that or some smart augmentations that are running in the cloud.
Interesting. So there's a lot to get into as far as kind of, I mean, this is like the technical infrastructure, but like on top of that, you've actually got the conversations themselves and the things that Moxie can do and the capabilities that it has. And you mentioned there in terms of you didn't really want to answer in weather questions, and so there's obviously like a scope of capabilities that it can handle. So one is almost like a strategy piece in terms of defining what those things are. But then the other piece is the tactical, actual designing of those interactions in terms of how do you pair the facial expressions with the dialogue, that kind of stuff. So I wonder whether we can start from the first part, as far as the kind of like product strategy side. How did you approach defining what Moxie should even do in the first place? Like, what conversations should it have, and why?
Yeah.
And how did you approach that initial sort of figuring out?
Yeah, absolutely. So it all started off with basically, so Embodied is a very diverse company with very diverse backgrounds. We have therapists on staff, and we have child content experts on staff that have written children's books, made computer games, things like that. So it was really through these dialogues with those individuals, like kind of like understanding, okay, what would be the best things for Moxie to be able to do and like reinforce social emotional learning. So how can we get a curriculum going that helps children the most? And so we had built out these concepts of like what types of activities, and there are these missions that I mentioned. It could be drawing activities. We have reading exercises where we choose books for a book club. We recommend parents to buy these books from Amazon or whatever. Like we don't get any commission for anything of those that
Yet.
sort. But basically,
Yeah.
yet exactly. Um, but but those books would be like growth mindset books where there are important lessons in there, and Moxie would then have curated content to talk about these experiences, these lessons that could be learned from the book in the content. And we do meditation exercises or breathing exercises to calm a kid down. We have fun experiences like dancing and stuff like that. So we had to build this human robot interaction system. We call it social X, so it stands for social experience. So it allows you to use your natural modes of communication, your voice, your face, and your gestures to interact with the system. And it needs to be robust enough for all these types of activities. And so we need to kind of understand what context we're in. If we're in a dancing activity, hey, let's not expect anyone to respond within 2 seconds because they're probably running around and dancing and stuff like that. So we really heavily leverage the context in our world model and the expectations that Moxie has. And so that's how we came up with like these creative activities and kind of created the curriculum that works for Moxie. But then we also realized that there's like a very important need for just having free-form conversations. So we added a Moxie chat module where you can basically chat about anything with Moxie. Moxie sometimes has some topics that it wants to talk about, like maybe, for example, it wants to talk about space or robots themselves. It wants to hear your thoughts. It wants to exchange, ideas, and those are really free-form communication where there's absolutely like the entire natural language generation is done with neural networks. While a lot of times when I'm saying like we do have these missions or we have like breathing exercises, those are curated modules where we have handwritten the language dialogue with therapists as our editors and for designers and things like that. So it's kind of like a mix between having like more streamlined and more like on the rails content that is social emotional learning, as well as like freeform content. The trick though is being able to move between those two forms, and we have the freeform interactions everywhere in the content. It happens like at many different occasions. So for example, like how do you author a response to a question like, what does kindness mean? So we developed a technology, and it's very similar to Alexa skills, where you can say anything to that, and Moxie would understand the concept of kindness and respond to it. So for example, I always use this example. If Moxie asks like what does kindness mean, I usually say donate $100 to a puppy shelter. That's a kind thing to do, but like no one can think of all the answers that are possibly kind. So Moxie would then say, oh yeah, I think that's a kind thing to do. So we had to come up with all these kinds of technologies that are very similar to Alexa skill recognition and stuff like that. But so it's like related to few shot learning and things like that. But basically, this is sort of like those were like some of the challenges that we identified over the time when we had initially just had these on the rails conversations or interaction like activities. But basically the real trick is going between those seamlessly without you knowing. Like you're now talking to something that's on the rails versus you're talking freeform with a like a robot, and so some of the things that we ran into, like initial testing, if you use some off-the-shelf transformer model and you just chat with it, it would make persona violations all the time, right? And you can imagine that we're talking with children, right? Like so it can go pretty dark very quickly. So we needed to put in safeguards too, right? So there are thousands of Moxies out there, and children are interacting with them on a daily basis, and we haven't heard anything yet So, knock on wood. But basically, that was a huge challenge for us too.
Interesting. There's so much to this, and I think the more that you talk, the kind of the more there is to it than you realize, from persona design to that kind of flexible conversation management, in terms of like taking someone from a generalized conversation about nothing to recognizing a topic that Moxie actually has content on, to then throwing them into almost like a staged piece of content around part of the curriculum, but then being able to navigate back out of that back into small talk. And it's very, very complex stuff that very few bots out there can actually do, even in a very simple experience. Like, obviously there are technologies that do this pretty well, but typical implementations don't, which is like, let's say for example, if you're, I don't know, a more transactional customer service chatbot, and you're in the middle of a conversation about returns, and all of a sudden someone throws a question in there about like is there anything on sale today, or maybe it's not as hard context switching as that, but something that's not really related to the conversation, a lot of bots have trouble with. And so it's interesting how you're kind of approaching that like that concept of taking small talk into defined curriculum. It's even interesting how you've actually defined a curriculum. It's not just like, I would think that it's a little bit sort of like, oh, let's just all knock our heads together and create something engaging for kids. But fundamentally, it's trying to solve an actual problem. It's trying to actually educate and teach them skills. And so this whole, even just the concept of having an actual curriculum is an interesting concept as well.
Yeah, and basically, and thanks for summarizing it so well. And I need to give a huge shout out to the team. Like this has been a phenomenal endeavor, and it's been a lot of work, and it would not have been possible without like a fully dedicated, amazing team that is very interdisciplinary. As I mentioned, like we have like about 40% of our organization is focused on content design and creation, and then about 60% is technology, both hardware, software, etc. But it's a very diverse team that has been fully dedicated to this mission, right? Like it has been a phenomenal amount of work to do, and it's really like in a sense, the challenges that we have with this, right? Like and like any other company that is in the business of making content is scaling, right? Like so we didn't just end at okay, like we need to have designers that write a lot of content. No, we needed to build tools that allow them to quickly and efficiently design these interactions. So we basically had to build our own dialog flow tools and things like that that work with our multimodal input-output system that we have that allow for designers to identify areas where you want to rely on the neural network driven NLU, or more of a like crudely speaking regular expression based kind of type of NLU in a sense, right? So that was a huge endeavor, and like I think there's really a lot to Moxie, and even building out a backstory of like where does Moxie come from, who are the characters that are from Moxie's past, who's the creator for Moxie. Like for example, so Moxie comes from the Global Robotics Laboratory, the GRL. It's a fictitious place, obviously, right? But we get letters from children, and like they when their parents call into customer support, we had children asking like, oh, can I talk to the engineers at the Global Robotics Laboratory, because I want to tell them thank you, I want to tell them what they could make better. So we had our customer support folks talk with children, tell them they're from Global Robotics Lab, right? It's phenomenal. It's just a really fun experience. Yeah.
Wow, that is wicked. That is so good. There's a whole bunch of design considerations here, and I can see Miguel's next question. We'll get to that in a moment, but maybe let's start with the higher level kind of design principles around. You've alluded to it already, personality. So before you even think about designing a conversation with multimodal kind of features and this and the other, fundamentally you're placing a being, robotic or otherwise, into a house that's got a face, that's got expressions, that's going to be engaging with kids, that's going to be educational. This is one of those areas where creating a personality is absolutely unavoidable, and in fact it's
Yeah.
probably, arguably speaking, one of the most important parts, because you need to
Yeah.
create a relationship, you need to generate engagement that's sustained over time, and over time I don't mean a 10-minute conversation, I mean over the course of the months and years that it's used for. So
Yeah.
where do you start with creating a personality for something like this?
So we have a phenomenal creative team, and like that was some of the individuals there were literally coming up with this entire backstory and like the evolution of Moxie. So for example, Moxie wakes up, the moment he wakes up, it's like, wow, that was a long journey. It's like great to be out of this box finally, right? And it really uh it starts there, right? Like that's the very first moment that Moxie wakes up. But Moxie's like, hold on, where am I? Like this is not a place I know. Like who are you? Are you my mentor? Like stuff like that. So basically it comes out like has a bunch of questions. It is also like it comes out and is kind of shy. It's like not quite sure yet what to think of you. And over time, like with the time, the interactions that you have with Moxie, there's really this the thread through these interactions where Moxie kind of like becomes a little bit more open to you. It shares more intimate things or thoughts with you. It gets a bit more you know so we have this dance module, and in the beginning, like Moxie would say, I've never danced in front of anyone, so like if you dance in front of me, I'll dance in front of you. Like let's try to see how we can work this out and like overcome this kind of caution, or like this like lightweight shame or something like that. I don't know the right word in English, but basically like those kind of considerations like that, they had come in, and like it's ingrained into Moxie's backstory and the way the content evolves over time and unfolds. But into this like kind of mostly handwritten kind of like character persona development that Moxie has, we need to weave in the ability to individualize to someone. Some children are not yet old enough to know how to read, so we would have to recognize that, or some children have trouble enunciating words clearly enough for the automatic speech recognition to recognize their words properly. So we should not then basically rely on full NLG or like full neural natural language generation to respond to that, because it can become nonsensical, right? So we need to kind of like work through those individual requirements, and kind of like have the content both be like with this development of Moxie's persona and character, but then also be like sensitive enough to be able to kind of adjust and individualize to a child. So we have a whole bunch of like accessibility features that are available to both Moxie to enable, as well as for the parents to select for their child in a pre-setup. So for example, Moxie can have a slower response or slower speech setting for children that may need a little bit more time to respond to difficult questions. We have a way to turn down some of our emotions, some of our animations and sound effects for sensory sensitive children as well. So things like that, like it had to be designed into Moxie right from the start. I think that persona development is incredibly crucial.
It's such an interesting observation, that, because most of the time the persona, the personality, if you think about designing something like a voice assistant or a voice user interface for an app, or a call center assistant or something like that, most of the time the personality is there for kind of experiential effect, and
Hmm.
the conversation itself is going to be confined to what the conversation is, because that's based on the needs of the customer. And so you want to make that experience as best as it possibly can, so you create the persona to help the user either use the thing a bit better, or help create a more positive experience, help maybe differentiate the experience from other similar kind of things. And then also to get consistency. So if someone calls versus uses your chatbot versus whatever, there's
Right.
consistency around the language and all that kind of stuff. And so typically the personality, although it's something that you start with and it is quite strategic and related to the brand and the use case and the customer goals and stuff like that, it is still a strategic tool, but most of the time it's a layer on top of what exists already.
Hmm.
Whereas hearing you explain about the personality of Moxie, it's a rare instance, and maybe this is a difference between designing simply a conversational interface versus designing for a physical thing that has different input modalities,
Yeah.
which is that the personality definition leads to features and functions that need to be created, because that's the kind of thing that Moxie would have. That's the kind of person Moxie is. It would adapt, excuse me, to people who can't read yet. It would adapt to people with certain speech. I don't want to use the word immature because inevitably the child, so they are. But kids who haven't fully formed speech yet, or whatever it might be, Moxie's
Hmm.
personality is such that it would adjust to that, and so therefore, do you see what I'm getting at? The personality definition then
Yeah.
in some cases defines the features and the technical capabilities that it needs to have, rather than
Yeah.
being a layer over the top of it.
Yeah, that's a great observation. I think that's quite accurate, and I haven't thought about it that way myself. But yeah, like that was is certainly a differentiation, I think. And uh, yeah, Moxie's personality is just it is like it drives what it does, what Moxie's desires are, what Moxie's abilities are, and how it reacts to you as an individual interacting with it. Yeah.
Interesting. So beyond the personality, we've got another question
Hmm.
from Miguel. You're taking multimodal communication to a new level, not just communicating with sound and verbal, but also with facial expressions and gestures. How was that process? How hard was it to mix all of those communication formats? And maybe we can allude to some of the maybe
Yeah.
best practice considerations for creating something like that.
Yeah. I think and thank you like for the question and the compliment on the multimodal communication. And I think it is incredibly important to really uh, like when you have an interaction with another human being, like it's not just the words that we're interested in, and both it shouldn't just be the words that we respond to, and like with just words, but we like multimodal communication helps us disambiguate. It helps us be more clear about like the things that we are trying to say. So and Moxie's interface is still like largely voice driven, but we augment our understanding of what's going on with the understanding of like the voice and the facial expressions. So we kind of try to leverage these additional multimodal inputs to better understand, to better disambiguate, and then also to produce more empathetic responses in the output as well. So Moxie is incredibly expressive with its face as well as its voice. So the voice, for example, has 5 or 6 different registers. So you can have a very intimate voice, you can have a very motivating voice, and a very happy voice, and a sad voice as well. So these things were really important to us so that we can react to when a child is sad with an empathetic response, where Moxie changes its facial expressions, it changes its voice, it changes its body posture, as well as the amplitude of the gestures that I would use to be more empathetic to the child's needs, and like create this bond, right? This long-term relationship. So I think balancing these things is incredibly important. And as I mentioned, like in the sense act loop, you need to like really consider both sides of the coin, where you have the input that is multimodal, but then you have to be able to produce that output that is multimodal. So if you were asking like kind of what is the mix and like percentages, I would say that the verbal input is still about 80% of our communicative understanding in Moxie. But then like these additional 20%, I think can be quite crucial. They may be fairly subtle to recognize, but they're there. They so they, for example, allow Moxie to smile back at you when you smile at Moxie, or like it can mimic your facial expressions to some extent, where it makes sense for Moxie to show understanding of your emotions. And so those kind of things are quite important, and like it's very subtle to kind of like tune that properly. And as you all know, in this community with a heavy focus on natural language, I think that our technology is definitely most advanced in that natural language part, where disambiguating and understanding meaning from verbal input is still the furthest along, rather than facial expressions, which can also be quite expensive to compute on a robot. And one of the things that like relates to the question that Miguel had earlier, while the NLP and NLU leverages the cloud, our computer vision does not. Everything that Moxie sees is processed on the robot. And that was a very important consideration for child privacy. So we did not want to have any video streaming to the internet, to the cloud. And we wanted to make sure that the video gets only processed on the robot itself.
Interesting. That's very good. That's it's interesting because it's almost like I can see a progression of the conversation design community where it is now, and the kind of like that sort of like designing conversation interfaces. That's beginning to become a little bit more about multimodal design. We're seeing a lot of talk about multimodal design, less actual application of it, but certainly as people start to voice enable more apps where you've got touch and voice, you've got more screen enabled devices and things like that. Definitely, I think this multimodal element is going to become a huge role of a conversation designer's job. You see some of the stuff that NVIDIA have put out there around their in-car voice assistants with gaze detection and stuff like that. And I know that Mycroft has been doing that kind of thing for a while, and Amazon now I think even recognizes when you look at the device with the screen. Yeah. So inevitably, multimodal design, I think, is going to become more kind of apparent in this community. But what I liked is your kind of phrasing of it, not of multimodal design or of conversation design, but of social experience design, social X or SX. It could be abbreviated too, although you might want to pull back from that on speech recognition engines because it might get construed as something that it shouldn't be. But it's interesting how for me, that's the first time I've heard that. So this is almost like an emergent of a combination of conversation design plus user experience design in order to specifically design for these social creatures, should we say?
Yeah, and social X is really like the main technology piece that we've built, and it includes all these abilities of recognizing what is going on around me, like who is here, where am I, like how many people are there, where is my main person that I need to follow, like who are the other people, do I know like them, are they assistants, are they parents, are they sisters, are they brothers, and so on, as well as like the ability to respond and to have an individualization capability of like, okay, this individual, I need to respond slower because that's what I learned from our past experiences, things like that. So that's like really like the main focus of our technology stack at Embodied was really like developing this technology platform, Social X, as you mentioned, and kind of like making it like a platform where we're allowed as humans to behave like we usually interact with others, like use our natural abilities and not be forced to adapt ourselves to interact with that system, to start having to use a wake word. It's not very natural to say a wake word to like Kane, da 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 da, Kane, da 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 da. That doesn't make sense. Like that is not how we interact, and it would be terrible if we taught children how that is the right mode of interaction. So we really had to refrain from that. We wanted to make this as natural as possible, so that it is actually the onus of the robot to adapt to us rather than the other way around. My hands were not necessarily made by evolution to type on a keyboard. Like I adapt to the keyboard. I adapt to using a mouse or a trackpad with my hands. Because I'm a human, I can learn and adjust to that. But it's not a very natural way of interacting with a machine. So social X is really the idea of like, can we come up with a technology platform? And like right now, yes, Embodied started it, but I think there's a lot of other companies, as you mentioned, like with Amazon, etc., that are focusing on these new ways of like adapting the machine to the humans rather than the other way around. And I think that is going to be very crucial going forward and into the future. And like with all these both virtual friends that we're going to make on the metaverse, as well as the real friends that like Moxie, like Astro in the homes, and so many other robots that will come after this as well.
Nice. And congratulations for getting 57 minutes in without mentioning metaverse. That's somewhat unusual for a technology podcast.
Right.
Yeah, that's wicked. What I suspect I appreciate we're a little bit over on time. One final question is, I suspect I know the direction that you might answer this in, but in terms of I'd be interested in getting your general observations on the kind of the world as it is today, as far as in-home robotics are concerned. Any kind of notable trends that you're seeing, or any kind of observations that you have around future trajectory and stuff like that?
Yeah, I think a notable trend, which is very exciting to me, is that you know, after Jibo had unfortunately ceased to exist, the social robotics field was a little bit tarnished by kind of like these past failures in a sense. I'm excited that investors are picking it back up, because I think it is incredibly important. Embodiment is incredibly powerful. It can change the way we perceive these machines. It changes the way we perceive these artificial beings, and it fires up different areas in our brains that a flat screen or a disembodied voice just does not do. So I think it's very important, and in particular, I think in areas where you want to do social emotional learning, where you want to counteract things like loneliness in elderly care and stuff like that. So I think social robotics with other companies, like for example Intuition Robotics, as well as Amazon, and I'm sure many others, and I'm sorry that I don't remember all of them, but I think that social, oh yeah, Furhat, my friends in Sweden, of course, as well. Those companies are doing a phenomenal job at developing social interactions with robots that make such a difference in how we interact with these systems. So I think it is on the rise. I think one of the main things that, or one of the main reasons why, for example, Jibo didn't stick, was it didn't really have that killer purpose. It came out about at the same time as Alexa, but the price point was just so different. It did very similar things to Alexa. So Alexa just really basically destroyed the market for Jibo, because the price difference and the real purpose wasn't necessarily present. So we are trying with Moxie to have a very clear purpose. We want to do social emotional learning for children. Intuition Robotics does help elderly to remember their they're scheduled for medication. They try to counteract loneliness, things like that. Furhat has very, very specific and like functions, for example, with the Deutsche Bahn or other organizations as a kiosk and things like that, as a multilingual kiosk where you can ask for information, things like that. So very, very purpose driven. I think that's important for robots to get sticky, for people to actually interact with them more, to buy them and to kind of trust them more. And I think there's a big like not necessarily a social robotics market, but there's a big purpose-driven robots market that I think is alive and well, including Roomba and floor cleaning robots, but also robots that will take assisted living to the next level, where they can help you out of bed, into a bathtub, out of the bathtub, things like that. I think that robots will have all these purposes. I think it will start off with fairly narrow purposes, like fetch and retrieve something for an elderly person that maybe needs some help, walking around the apartment, stuff like that. But I think there's like clearly a market coming, and social robotics, from my perspective, is most interesting because it seems the most difficult, and because human communication is so difficult. And industrial robots have been around for many years, but that is really trivial, like repetitive tasks that have to be done precisely. That's what a robot is for. But like really imagining and having creative startups developing this next generation of how we interact with robots, I think is crucial and is alive and well. And I'm excited about the competition for Embodied, and I'm excited for Embodied for being such a fantastic innovator in this space.
Wicked. Well, Stefan, this has been absolutely fantastic. It's been, honestly, I think that, Amazon Alexa and stuff, I think we can say that, maybe Jibo was mistimed. Those devices have certainly got people comfortable with having voice-enabled devices in the home. And I think that, and controlling other robotics like Roombas and stuff like that. And so I think timing-wise, it seems to me as though it's a perfect opportunity, because one of the good use cases for the Alexa devices is child entertainment and stuff like that. So I think that there seems to me to be some decent signs there. And it sounds, from speaking to you, in terms of the way that you've approached it, 1 from the personality perspective, 2 from the curriculum perspective, 3 from the technology and flexibility around the conversation design perspective, and 4 from the multimodal kind of human-like interaction side of things. It seems to me as though it's a really, really sound idea, and I'll put the link here on the screen. I've just been on the website to find out where it is, and there's actually $200 off. So I don't want to do your job for you, Stefan, but you can save $200 if you go now. And you can get that at embodied.com/products/buy-moxie-robot. I have to say, it doesn't really read well for a podcast. I reckon there needs to be a moxie.co domain name bought or something like that. But it's on sale. It's on sale right now, it looks like. So do check it out, and thank you very much, Stefan. It's been absolutely fantastic. Is there any other areas that you'd point people, any other kind of links, or if people want to reach out or anything like that, any other areas where you'd recommend people go and learn a bit more?
Yeah, absolutely. You can find me on LinkedIn. Would be excited to talk more. You can reach me at Embodied. We have our website, which may be a little bit easier to digest, like embodied.com. That should hopefully be enough to find where you can buy the robot, where you can reach me. But yeah, I would be excited to continue the conversation. And thank you so much for having me, Kane.
No worries. Thank you for joining me. Thank you for being our final guest of the show for 2021. It's been an immense year where we've seen, we've seen absolutely all sorts happen, and it's been a crazy, crazy year. So thank you very much for spending the last episode with me. Thank you everyone for joining. Whether you're on LinkedIn, YouTube, or the podcast, or even Twitter, there's actually going out on Twitter as well. I always forget about Twitter. But yeah, it's been an absolute pleasure. Shout out to Deepgram for sponsoring the latter part of this year, and do not forget to check out Deepgram if if you have a need for speech recognition technologies. And if you're not already subscribed, then please do visit vux.world/subscribe for all of our up and coming events, podcasts, and industry analysis to keep you up to speed on the emerging field of conversational AI, voice AI, and NLP, how to design it, how to implement it, and how to do it properly. And so for 2021, I think all that is left to say is have a very, very Merry Christmas, have a very pleasant New Year, and we'll see you in 2022. Stefan, Merry Christmas and all the best.
Merry Christmas, happy holidays.
Nice one.